Today you're going to be working with what's called the right-hand rule. This is used to find the direction when you're dealing with a magnetic force problem. In yesterday's lab, you saw that there's an important relationship between magnetic fields and electric currents. This happens because magnetic fields are able to exert a force on moving charges. It also turns out that an electric current is simply a series of moving charges. That means that a magnetic field will be able to exert a force on a wire that's carrying a current. One important note is that in magnetic field problems, the velocity, force, and magnetic field vectors must all be perpendicular to each other. Since all three of those vectors need to be perpendicular, it turns out we don't actually need any math to be able to determine direction in these problems. Instead, you can manipulate your hand in certain ways. Now, even though we refer to this as the right-hand rule, you're going to be using both hands. When you have a positive charge, then you're going to use your right hand. The way I remember this is that positive charges are protons, which have an R right at the start. When you have a negative charge, you're going to need to use your left hand to get the directions correct. The way I remember this is negative charges are electrons with an L right near the start. Now, even though we know that current is almost always moving electrons, because of the way current direction is defined, we're going to have to treat it as positive charges, which means that when you have an electric current, you will use your right hand. To use the right-hand rule, you'll flatten your hand and then use different parts of your hand to represent different vectors. Your thumb will need to point along the charge's velocity vector. Your fingers, meanwhile, will point along that magnetic field vector. And the force vector would be pointing straight out of your palm. All right, let's get an example. So first up, we got a proton. That means I'm going to have to use my right hand. I'm going to take my right hand and I'm going to stick my fingers straight up and my thumb straight to the side, get everything nice and flat. All right, so it says this proton is moving up. Since my thumb represents which way that proton is moving, I need my thumb pointing straight upwards. It's in a magnetic field that points to the right. My fingers, I've got to point along the direction of the magnetic field, so I am rotating my hand so that my fingers point to my right. And then it's going to experience a force straight out of my palm. So there would be a force coming straight out of the screen in this problem.